And Cloud and Cloud Tech community is driven by the group of people, and as the volunteers, we help them to empower on their tech careers. People maybe come from the different experience. Somebody may be junior, somebody maybe have a 20 years of experience. We share the knowledge. We post on a medium. We help them to empower their technical skill. We help each other and grow together. And it has a common objective of helping the cancer childhood children. And we are doing a best of our abilities. Okay, and who we not only we did like this, we have empowered the people from the introvert to the extrovert, become a speaker, and we have great success stories. And people, ladies who want to restart their tech careers, they formed a very good network within here and became a tech ambassador in the industry. Okay, that's about the Cloud and Love. Let's jump into this today topic. This is the agenda for the day. We are going to talk about AWS Foundation Model. We take few minutes to talk about the AWS Foundation Model. Then we will discuss about fine-tuning and overview. Then we are going to talk about the Llama, the recent model Llama 2 at a high level. Then we do the demo of fine-tune the Llama model using AWS SageMaker. And this is INRG, and it's about me. This is INRG Krishnan. I have 18 years of experience. I'm currently working as a vice principal and principal engineer in a financial organization. I'm an AWS community builder, and anybody who want to connect with me on a LinkedIn, you can connect with me on there. And I have discussed about multiple topics on AWS, SageMaker, MLOps, and GenAI recently. And I have around 50 plus industry certification, and I have 11 AWS certifications. Okay. This is about me. And people who not got a chance to attend the previous sessions, please feel free to go here. If you want to take a snapshot of this, you can, or you can go bit.ly cloud and loud -GenAI. You will have all the topics we have discussed. We started with the generative AI as a beginner builder's guide. And then we started leveraging the large language model in enterprise using a foundation model. And all the session we gave a demo and the labs. And the third session, we have discussed about the transformer and prompt engineering. So I have just given only the prompt engineering details as a third session. Okay, we have done the lab exercise using the playground in AWS Foundation, AWS UI, as well as we taken the API from one of the AWS Foundation model for the large language model, as well as the image model. And we have created within a demo. Okay. Somebody putting a question here. Okay. Archit Agarwal. Okay, I can take a questions, but go on, Archit.
I was just asking for the links. I think someone
Okay, okay. You can put it. Anybody who have a question, feel free to put it on the chat, because sometimes you tend to forget what you want to ask. Feel free to put it on the chat. I will read it at the middle of the middle or at the end of the session. Okay. Thank you, guys. And we have few more feedback came from the meetup. They are interested into learning AWS SageMaker fundamentals. I'm just top 3 topics based on the feedback I got it. AWS SageMaker fundamentals and where to start with the GenAI. And the another topic there people asked about MLOps. Okay, so I understand these are the 3 topics. Many topics came out of the 3. These are the 3 topics I feel a lot of people are asking. So I'll find out time and definitely start again. Okay, so you are saying it's giving a 4-over error. Okay, let me check why it is giving. Yeah, I understand it is giving a 4-over error. 1 minute, I'll give you the playlist itself. Give me a minute. Okay. Okay, I think that's a typo. Okay, you guys can check on this link. Okay, you can see this information and put it on the chat. You can take this one for that. Okay, thank you. Let's go. These are the foundation. model. Guys, if you are not understanding what is foundation model, nothing wrong. You can ping me. I can take another 2 or 3 minutes to give you the information. That would be helpful. I want to make sure that you guys have a better idea about it. Okay. These are the foundation model available in AWS Gemstart, and it starts with the stability.ai. They have multiple model for different tasks, for text to image and image upscaling. And they have given, there is a recent model announced by the Stability XL, which give you better quality of the image model. And we have Alexa TM, which is a teacher model. Okay. And we have many tasks can be done by Alexa model also, and a lot of models from the Hugging Face is available here. These are the publicly available model. Publicly available in the sense you can use this model with directly download this model, and you can fine tune the model and do some task based on your requirement. But there are other proprietary model also part of the foundation model from the Cohere. If anybody attended the previous lab, you have seen that I have given a session on the Cohere API, how to do the prompt engineering using a Cohere API. And Lighton is another proprietary model, and AA21 Labs. Okay, anybody who is following this AA21 Labs, you would have seen there is a first model which is taking a context of 10K of the context length. Okay, and recently the Llama model, Llama 2 model, which is publicly available, is also part of the SageMaker Foundation model. Okay, so anybody who have AWS console, you can go to the AWS SageMaker and you will able to get an access to it. Okay, so I'll give you some quick review. So you go here, this is the AWS console, go to the foundation model, and you will able to get it. If anybody not having this access, you need to raise a request and you will get an access to it. This is the recent model, the the stable diffusion from the stability.ai. And this is a Llama model. You will have the chat model, and as well as you have a instruction to the model for the chat model, and you have base model also. You will see those models details. Okay, and few of the model are a proprietary model, and few are not open source model. That you have to go check on the model cards, and you can able to get those details. Okay, so these are the Hugging Face models. Okay, so if anybody who don't want to have access, go ahead and to this your AWS console, go to the SageMaker, click on the Jumpstart. You have a foundation model. Okay, you click on it and you raise. If you don't have an access, raise a request. You will get a foundation model access. Okay. Okay. That's about the foundation model. And what is foundation model? Okay, I'll spend a couple of minutes on what is foundation model. Okay, the foundation model are the base model trained by the corpus of the data. Okay, I say internet corpus of the data. Okay, it's a self-supervised learning. Okay, it's the unstructured data they have given and trained. Okay, they are using the architecture called transformer architecture. People who not attend my previous session, feel free to go and check those session. I have discussed detail about what is transformer and how we are using it. We are going to touch upon, but we are not going to be touch upon detail on what is transformer architecture. We were using a transformer architecture. Some models use only decoder architecture, some model use encoder architecture. Take example of the chat GPT or that is using a decoder architecture. Some models like a Llama 2, it is using a autoregressive model, both encoder and decoder architecture. So each model will use a combination of encoder and decoder, or only a single alone. So using this model, they trained a large corpus of the data in the I say in a high parallel cluster, and they created a base model. Okay, and this model, you can use it for multiple purpose. You can do the text generation, you can do the question and answering, or you can use it for the code generation. Okay, so the recent model by the Meta AI, the Llama 2, is on par with the ChatGPT 3.5. Okay, they set the big industry standard, or they set the bar of how the instruction fine-tune model or the supposed to work, and the Meta AI is almost reaching it. And the good thing is you can use a SageMaker and a single click of the button, or with a minimal activity, you can deploy in within your VPC with in secured network, and use your data to read, fine tune and use it. Okay, so this is about the foundation model. People who not understood what is foundation model more after you can feel free to go back to my previous session. You will get more details on it. Okay, let's go over the next one. So this is a journey. Okay, see, there is no one size fit all. Okay, you can, and some company ready to take one small task. They just want to have a chatbot for their, take an example, you are running a travel company, you want to have a chatbot. Okay, so that is a very small use case. Okay, so you can take a model which can perform only for your use case, and fine tune it and make it for your use case. So you are not from the day one, you are not going to pre-train from the model from the scratch. Okay, if you went to my previous session, I have given you the example how much money you have to spend if you want to pre-train the model. Okay, we are done one epoch of the fine tuning, and I will give you the numbers how much we have spent for the fine tuning. So always you need to first understand what is your use case, whether it is a chat, whether it is a text to image, or you have an image upscaling. Based on your use case, you need to find what is your foundation model. Once you identified your foundation model, you first check how whether it can work with the prompting. Okay, whether with the prompting is it solving your use case. There are multiple framework or the wrapper for the prompting, or the prompting platform environment like a LangChain can help you to achieve your task in a better manner. People who not understood the LangChain, feel free to go and check the previous session. I have discussed detail about the LangChain, and we did a few of the use cases also. There are multiple ways to do the prompting: few shot or React or zero shot prompting, even a RAG, okay, retrieval augmented generation, like using your own company data, how you take the data, embed that in the embedded store, and do the prompting and retrieve and given you the result. Okay, there are multiple use cases you can use the prompting and do it. Then comes the fine tuning. Okay, so if the prompting is not uh, if the prompting is not working, you can always, then you can find out, you can use a technique of fine tuning. Okay, then there is a journey called RLHF. Okay, so reinforcement learning human feedback loop. Okay, so the chat GPT or the Llama 2 chat model are working in a really well, in a very good manner, or it is giving the better evaluation metrics only because of the RLHF. We will touch upon on that RLHF on the next session. Then there is a pre-trained model where we are doing a model right from the scratch. Okay, uh, so that like a Bloomberg GPT. If anybody who in the finance industry you heard about it, you can talk about the Bloomberg GPT. Bloomberg is a company. They have all the finance data. They taken their data and they trained the model from the scratch for their use cases. Okay, and they have spent around 700 million based on this compute they have used. I have calculated it is almost 100 million. Okay, so if you have that much money to spend, then that is that up to the requirement. Okay, so fine tuning the model is what we are going to focus on today. Okay, so this is the SageMaker example of the pre-train. Okay, before I'm going to the fine tune, I want to talk about the complete pre-train, what it takes. Okay, sorry if I mistake with the numbers. I will I will reconfirm the number. Okay, so there is a question from Kiran. Kiran, you're asking for the previous slide once. You can check the YouTube video. It has all the informations. Okay, uh, billion tokens. They are trained with 365 billion tokens, which are all Bloomberg data set, and they have a web data set, news and filings, and press information, and the Bloomberg proprietary data set. Along with that, they have taken the data from the pile. Pile is nothing but a public internet data sets, where like okay, and Wikipedia, all the data sets they taken, and then they train the model using P4 D4, it's a P4 GPU instances. It's 24x large instances. So it take 50K per day. So I'm talking about it take 1 day. If you want to train that model, it will take 50K. Okay. And it use a elastic fiber adapter because it once you're doing the parallel cluster, right? To internode connection, you need to have a better network. So they were using an elastic fiber adapter. Then the data set, okay, the very important thing is the data will need to be distributed across the in a distributed environment. So for that, they are using a FSX for Lusher. Think like your EFS or your network file system, but it will give a better performance. So underneath it will use the S3, but the S3 data will be warm up and loaded into the Lusher, and they were using a Lusher to store their data. And SageMaker have some library called SageMaker model parallelism, because the model cannot fit into the single GPU, that has to be distributed into the multiple GPU. So they were using a framework called SageMaker model parallelism, SMP, okay, and to span across the multiple instances. So you can see the output of the SageMaker example. Okay, so they are asking who is a CEO of Silicon Valley Bank. The Bloomberg GPT give one information. At the same time, it is the Geo GPT Neo X give a three information. Okay? So you cannot have a three CEO for the company for the one division or one thing. Okay? So that, and once you are able to fine tune with your own data from the scratch, you have a lot of flexibility. Okay, and it give you the better output based on your requirement. And very important, the big challenge is the compute cost. You end up in spending more money. And Bloomberg is it has a lot of data, so they are able to bring those quality of the data to train. If anybody heard about the recent trend, by 2026, the AI will get the plateau, not because it's incapability. We as a human, we are not able to train with the quality data. Okay, so the only the data is a king. You the good quality of the data you give, the better you can do, and the time to train. So it's a iterative process. It's not a single time you have to do it. So it's an iterative process sometime, and you have to train the model, validate it, and you need to check the performance. If the performance is not good, then you have to retrain. So it's an iterative process. So now let's talk about fine tuning. When and why. Okay. So if LLM acquire the new knowledge through the weight updates. Okay. So the large language model learn the able to learn the new knowledge, whatever the corpus of the data they have. They learn the new information by a prompting, like a few shot prompting, or using a retrieval augmented generation, or you need to pre-train from the scratch, or you need to fine tune. Okay, so if you want to have a new knowledge, let's say you are a specialist in the biomedical data and you want to train your model only for the biomedical information, then and you are sure that the current model is not giving you the right output as you expected, that is where the pre-train or the fine-tune need to be done. Okay, then you imagine like a model weights or long-term memory, and prompts are short-term memory. If you are giving a few short prompt, it's like a short-term memory. Okay, and but if you are changing the foundation model, it's like a long-term memory. Okay, so that's analogy. Okay, so if you need the long-term memory, you need to have a model which can be done for your use case. Then there is a requirement for fine tuning. And one more challenging with the prompting, right? There is a context length restriction. If you have more than 4096, uh, I think Llama 2 is 4096. More than that, you cannot put it on the context data. Okay, and every model has a separate limitation. Okay, and the more context length, the inference cost also will be a challenging. Okay, then third one is use case. as I said, if you have a separate chat, want to build a chatbot using for your travel company, and it need to stick only for your particular use case of the travel company, then you better to do the fine tuning the model from the scratch. Okay, how how are we going to fine tune it? Okay, so now let's talk about the full fine tune. Okay, here we have example of set. Let's take an example of sentimental analysis, and you have a data set. Okay, and which is a pre-trained model. You take any model. Let's say take a llama model. Okay, and you want to fine tune completely the model. Okay, so one challenge, right? Here you think about the memory. This is a dimension of the data you are feeding in 512 into 512. But if you go to the llama model, it's even the basic model llama 7 billion parameter is 5120 dimensions. Okay, so it will occupy more memory. Okay, and another challenging with the complete fine tuning, right? There is something called catastrophic forgetting, because it will completely forget the generalization and only able to answer the particular task you have generated. Okay, so here it is giving you, take an example. Now you did a complete fine tuning and it is asking restaurant is okay but coffee is bad. What is the sentiment? The sentimental is negative. So how you do at the high level is you have your data set and you have pre-trained large language model. Take your choice of the foundation model and you do the back propagation again, and in an iterative manner, then you will have fine-tuned large language model. Okay, you can use a Sagemaker to do it. Okay, but the challenge for the full fine-tuning, right? It's same. It have a compute cost and it is like a complete pre-training, but you are not pre-training the model from the scratch. You are just only the fine-tuning only for your data. Okay, I have question from Fran. Go on, Fran. Go on.
Yeah, I was wondering what is the expected performance drop of the foundation model if you fine tune it in your own data. So let's say, we all know that GPT-3 or GPT-4, once they release the fine tuning option, it's capable of solving, I don't know, math problems and stuff like that, right? So if I would fine tune it into my own data, will I lose that performance, and how much of that performance will be lost?
See, it's two things. One, what kind of technique you are using. If you're completely fine-tuning it, you will lose it will learn to the generalization. That's what we call as a catastrophic fine-tuning. It will only able to understand your data. It will lose it is not a database, right? It's a reasoning engine. Okay, what the reasoning engine for work well while it is doing a better generalization and find the next token in an optimal manner. Okay, but if you are doing the full fine-tuning, it will learn only your data, and all the weights and biases will be tuned in, which will only fit for your new data, but it will not able to understand your old data. That is where there are new techniques which we are going to discuss next slide. Okay, you're talking about a 3.5 which they recently announced for the fine tuning. Okay, that it's just launched. I say it is 10 days back they have launched on the fine tuning. And not only this, there are multiple way you can do that. Even the lang chain, you no need to come to the complete fine tuning with a single data. I would say it's prompting slash fine tuning, which will work for your task. Okay, but if you want the quality performance, you need to do the complete. You need to do the fine tuning using a QLoRa or LoRa, which we are going to talk about later. Okay, and if you go to the 3.5, the fine tuning, you can see the limitation. It will not fit for all the use cases. Again, it will come to the challenging of the context length and the data set challenges. And if you're doing the fine tuning, you will not only pay for your language model, you end up in spending more money for the fine tuning task also on a 3.5. It's expensive, right? It's depend on the use case.
Thank you.
Okay, Vamsi, if you want to convert natural language to SQL command with your own database, should we need to find to them? Well, natural language. I think that you no need to completely do it, Vamsi. Okay, you can use the foundation model and find what is the gap. Most of the foundation model, like a Llama 770B or 7B, can if you are hosting by yourself or you are using Hugging Face, you can do it. And if you are finding a gap, then you train the model or fine tune the model. Don't fine tune the model right from the beginning. Okay, it's a journey. You need to start with the prompt foundation model, play around with it, do the prompting and see what is the gaps. Okay, then note it down. Then you have take a data set of say thousand lines of the data sets and do one epoch and see how it is working, whether it is giving a better performance. Now today's session we are not talking about evaluation. We have a future session we are want to cover the evaluation also. So that the life cycle need to be matched, done properly, otherwise we are hitting on the wheel without going nowhere. Okay, next one, we are using LoRa. Okay, so what is the advantages here if we are using a FP32 and if you are completely tuning the whole model? Okay, we are spending more memory and CPU. Okay, but if you are using a LoRa, like the low rank adapter, okay, so it add as an adapter rather than completely train the model. It will only train that uh, portion of the model. Okay, if there is a layer, right, in a transformer architecture, only for the feed forward network, it we will add as another adapter. It will uh, not, it will do the matrix proportion. If anybody worked on the matrix 512 into 512, if you're changing 512 into 1, then the matrix size will come down, the memory footprint will come down. That is what at the back end it is doing. Okay, so it will frozen the complete weights of the current transformer of your foundation model architecture and add as an adapter, and we will train only that model. Okay, that will give you the better it will give you the better results, and you can fit into the model into the less compute and give you and you can fine tune your model in efficient manner. Okay, and anybody interested more, you can check on this one. Okay, at the very simple is it just to do the matrix decomposition. uh, yes, there will be a lack of accuracy, but that is acceptable when compared to the compute and the money you want to spend. Okay, then comes the QLoRa. Okay, so the quantization, right? What is the quantization is? We are talking about 32-bit here, and most of the model you take the Falcon 40B, or most of the model currently they call it as a BF16. Okay, which is a bit float of 16. Okay, this is a 16-bit float where the model is trained upon. Okay, so what QLoRa do is it completely it will change from the 16 GB to the normal float 4. Okay, so the easiest example I can talk about is if you are dividing the pie, it will give you 3.14 some excesses number, right? So if you are using a float, it will reduce the amount of the decimals. Okay, so that's what happened here. What it do is it will change the base model into the 4-bit, so your size will be reduced, and then it add the QLoRa adapter. Then you can the model, the whole model can fit into the single GPU. So why the hello, sorry guys, I don't know from where you left. I think somewhere we lost the mute button. Okay, see, okay, I'll repeat this QLoRa QLoRa topic. Okay, so the advantage of the QLoRa, right? So all the base model, if you take a Falcon 40B or everything is a BF16. Okay, it's a bit float 16 transformer. Okay, so the base model is a 16-bit. Okay, but the QLoRa, what does it do? It transform to, it will make it as the 4B. It will compose into the 4B. It is a quantized model, and then it will add the low rank adapter. Okay, which will reduce the footprint of the memory in a very big manner. Okay, so you can fit it to the big model. Okay, so you can fit the 65 GB of the 65 billion parameter model into the single GPU. Okay, the advantage of this, yes, there will be a lack of accuracy, but the QLoRa, they are claiming that it is not lacking the accuracy. it compared to the 16-bit also. Okay, you can check that white paper I have given here. I have given you the complete details here. Okay. So what are we going to do today? Okay, so we are going to fine tune the llama model. Before, in the interest of the time, interest of the everybody, I want to give you the heads up towards llama model. Llama 1 model was released some early this year, but it is closed source or open source. It's in a confusion, but this model they have announced as an open source under the condition that you cannot use more than 800 million users or something. Okay, you can check on their thing. Okay, and they have spent half of the money only for the RLHF, where they did a human labeling to make sure the data is helpful and it is safety. Okay, so that's what the human labeling is the biggest cost. Okay, and half of the money they spend it for the fine tuning and training the model, and half of the money they spend for the data set alone. And they have a 6 variety of the model. One is they called as it's a fine base model 7 billion parameter, which is a small model. Okay, and you have a metrics for each one, like it's a code generation and common sense and world knowledge, reading comprehension. It has a for each metrics what the model is performing. They have 7 billion parameter, 13 billion parameter, and 70 billion parameter. Okay, this is the base model, and they also have one variant which you will not able to find it, but in your white paper you can see it, which is a 35 billion parameter model. Along with that, they have something called instruction tuned for model, like a chat model. That is also, they have a same variant, 7 billion, 13 billion, 70b. They have given some metrics about how much accuracy it is giving when compared to the chat GPT. In the white paper you can find it. And anybody who want to use this model, you cannot use it straight away. You have to go to their website and raise a request, and you need to fill in the form. Once they approve it, then you can use it. Okay, this is the AWS SageMaker Foundation Model console. You can see all the language model, llama model is available in a foundation model. Okay. Yeah, we were in a good timing. Okay, we have another 20 minutes to go through the lab. Okay, so what is a prerequisite is? We are going to do this lab. What is a prerequisite is? Okay, we want to get access to the llama 2. And better, you need to have a Hugging Face token. Sorry for the typo, I will change it. You need to have a Hugging Face token, and we are going to load the Hugging Face, the model from the Hugging Face. And from the Hugging Face, that we are using a Dolly datasets. It's a data set. We will see the data set also. Definitely we'll have a glance at the data set, and we are using these libraries. Okay, uh, for our use cases. Okay, we are logging into the Hugging Face, and we are using a transformer library for the tokenizer and for the cache file language model, and bit and byte config we are using for the LoRa uh, module. Okay, uh, and we are using performance efficient fine tuning. That's what we discussed on the LoRa, where we will froze the base weights and then add a LoRa model, LoRa adapter to the fine tuning. And how much we are this is the cost it happened for me. Okay, so I use this data set and fine tune this particular model. We are using a 13 GP model. I will go through it, and it taken me 9 hours 35 minutes. I'll show you those things. And I use this instance. Okay, if anybody want to do this from yourself, you need to raise a request for this instance from your AWS console. And this is NVIDIA A10, and it is a CPU of 16 GB and memory 64 and GPU 1, and GP memory is 24. The model size is 22. I was checking. So the cost per the maximum, the cost for this whole cycle taken is 16.4, and the fine-tuned model, the model output is around 22 GB. You will see all those things in our demo. So I think, any questions before I'm going to the demo? Okay, let me go to the demo. So guys, this lab is done by Phil Skimmett. Okay, if anybody who not following him, feel free to follow him. Okay, he posts a lot of good article, and with most of the article he send it with real-time examples. Okay, this is the lab we are trying to do. Okay, so first task, we are setting up the environment. We are installing the transformer. I am not going to run it again because it take 9 hours. Okay. So we are loading the transformer and we are loading the data sets and SageMaker. Okay. I want to show the Hugging Face data sets so that you will have better understanding. Hugging Face data set. Dolly. Yes. It's a Dolly 14K data set. So this is the instruction.
Are you sharing your code screen? Because all I can see is a lab overview.
Oh, you're not seeing it? 1 minute. Stop presenting. Okay, entire screen. Okay. Are you able to see my screen now?
Yeah.
Okay, thank you. So this is the data sets we are using. Okay, this is a 15K rows. Okay, this is the data sets from the Databricks, and you can go to the Hugging Face. You will see a lot of data sets here. And a couple of people pinged me that what is the best use case where they can use for the chat model. I have recommended them Falcon before some time, and now we can use the Llama 7 billion parameter web chat, and you can fine tune using data sets like provider data sets here. Okay, so this is a Databricks Dolly data sets. We are taking it. So we are logging in. Okay, I should not be using this. Okay, I should have masked it. Okay, anyway. So I load the data set. Okay, then
AJ, can you just increase the font size?
okay, definitely. Guys, okay. Let me know. Is it good now?
Yeah, now good.
Okay, you want to white or black? What is your preference, guys? Night mode is okay. Okay, so this is a data set. We were just testing the data sets. So this is the format of the data sets. It's an interaction. This is the instruction, and this is the context we are giving, and you will see the response and output also. Yeah, you will have answers. Okay, so the same whatever we are seeing in the Dolly set. Okay, we are giving. We can see it from here. Then we are tokenized. This is a model we are using, Llama 13 billion parameter model. And we are using a tokenization provided by the transformer. It is a pre-trained model. And we first do the padding. Padding is nothing but it will find out the end of the sentence, end of the line, it do the padding. Okay. The next one we are using, this is just a code we are using for the prompt template and keeping the all the data into the prompt template and chunk the data because you have to chunk the data because of the context length has to be matched. We are chunking at the 2048. This is a context length for the 13 billion parameter. Okay. Yeah, I got some error because I'm not able to run, but I fixed this error. Okay. Then what we did is whatever the model we are saving, we stored into the trained bucket. Okay. So I can go to my S3 console. I can show the data. It's all in a JSON format. Okay. If you want, I can show it. It's all small JSON file. They have stored it. Then we are fine tuning the Llama 13 billion parameter using a QLoRa. They have a script, something called run clm.py file. It has all the instruction about how we are doing this task of QLoRa. Okay, what are the trainable parameter we are checking, all those information. Okay, this code is not written by me, it's done by the gentleman Phil Skimmett. Okay, as I mentioned, please feel free to go and take it. In a slide, I have given you the details on where to take those, where to find this notebook. If you want, I can put it here. Okay. Oh, you want to see the JSON quickly? Okay. Yes. Go to the history bucket. So whoever want to do this lab, right, guys, I will share you the link where you can go feel it, take it out and try it. Okay. Audience. I'll give you that information soon. This is the history. So you can go here to that notebook. Notebook have that information about the history bucket. Go to the data will be chunked, okay, here, and then you go to the process llama dolly, okay. Llama dolly chain. Okay, it's a data set. It's a data set information. Okay. Oh, it's a small data, right? It's in a arrow format. It's a 40 MB. Let's see whether you can download quick. It is downloading. I'm not sure whether we can open with a bare file. Okay. Okay, so let it download. Meanwhile, we can go to the next this one. Okay, so first it will do the quantization, and it will freeze the model. Then it attach the LoRa. Then fine tune only the adapter layer while the frozen context for the context. Okay, this is the hardware requirement. As I said, we are using a 13 billion parameter, and I'm using the instance type to G5.4x large. And the maximum context length allowed is 2048. Sorry guys, I was telling 4096. I think I'm wrong. We can only do for the 2048 as a context window. So I think the data is still downloading. Here what we are trying to do is we are giving the path. We are downloading the container. Okay, so to do the training also, fine tuning also, I need the container. We will download the container. Okay, and the model ID, we have given the model ID before, which is a llama 13 GB. Okay, and this is a job name, which is a job name which we can see in a Sagemaker training job. And this is the data path where it will be stored into the container before while it is doing the training. And the training batch is 2, and we get the token. We will get it from the information we are given. The estimator is where we define all the parameters. Okay, so entry point, as I said, the run CLM file I was talking, right? That is where the train script was written. And this is an instance type, count, the role is IAM role, and transformer version. The hyperparameter is what we have given before. Okay, you see, this is hyperparameter we have given. And yeah, that's all. Okay, so we will give you the Hugging Face transformer dot fit, and then you give the training input data. Okay, let's go check the training input data where it is. I think it is from the history bucket only. This is a training underscore input data. See, this is the training data. We are using it. Okay. That is what you can see from this one. We are giving the training data information and data and fit the model. Okay, the estimator we are fitting. The moment you use a fit, it will start training the model. Okay, we are running this estimator fit with the data of the data we have stored into the S3 bucket. Okay, then it start training, and we did only one epoch, I think so. Yeah, 2 epoch we did it. And you can see it taken me around. Yeah, you see 89%, but of it completed. Okay, I can show you from the SageMaker console. Okay, I will quickly go to the SageMaker. SageMaker. I think the arrow file, I cannot open it. Okay, we need a file format, right file format, file opening. Okay, I will see whether I can open it after this, showing this. So you can go to the processing. You can show the processing jobs. So I previously did for the Falcon. Now I did it for the where is training? Okay, training jobs. You can click on the training jobs. So Hugging Face, Q LoRa. This is the training job. You see how much time it taken, right? it taken almost almost 9 hours. Okay, and we are using this instance count, and you can see the data, okay, and fully replicated. If you are using SMP, it will be distributed. Okay, and inside the container, we are using, this is it will load. Okay, and what is the directory it will source? It will store the files. This is a directory it will source. It will store the trained model. Okay, so I went and checked the trained model. It's almost 22 gigabyte. Okay, so we will see that also. See, this is the artifact. I can go here and check. So it is a 22 gig. Okay, so this 22 gig you can fit into the single GPU and and you can do the inference. Okay, so before that, you are talking about the data, right? I want to check whether the data you can see here. No. Source directory, how big it is. I'll download it and see. The arrow file, I'm not sure whether I can download. So source data. Okay, this is only the files which we are doing for the training job information. The data is under the same data path. Okay, so I cannot open the file, sorry, unfortunately. I'll check it, and I find it, I'll put it on the YouTube comments about the data. Okay, the data is nothing but the same dolly data sets we have taken. Okay, so that's all. Okay, this is what we have done to train, fine tune the model. Okay, we have taken the base model. I do some recap. 1 minute. Window fine tuning. I do the recap. Okay, we taken the foundation model. Sorry, I think I got this interview present. This is a recap. We have taken the Foundation Model LLama 2 13GP. We used this data to fine tune, and we fine tune using a Sagemaker using this particular instances, and we store the output into the S3 bucket. The next step is we use that particular foundation model, and you can create an inference. Okay, and then the next step is to do the evaluation. Okay, so those are the session we plan for the future, but that's all the demo I want to show to you guys. So the future session, we want to deploy the fine tune the model in SageMaker. Then we planning a couple of session on the LLM ops, and we also plan some session on deploying the recommendation engine in Snowflake using AWS SageMaker. These are the sessions we are planning very soon from our Cloud on Loud Gen AI Labs community. And I'm ready to take a questions, and I request everybody to pass on your feedback about this session. It will be great helpful. Okay, go on guys, share information. Okay, somebody like Tabriz Syed, full-time job. I understand, Tabriz, it's you want to look for the job, you want to post it here, and I have no issues as long as the people on the call not felt abused or anything. Okay. Okay. Girish Gowda, can you share the slides? Girish, sure, you ping me on a LinkedIn. We will discuss on it. Fran, you have a right question that I want to mention it. I spent around $16.4.
Hello, AJ.
Yes. Yeah, Fran. We have spent around $17 for this particular training job.
I see. And once you start the training, can you evaluate in each eval, or you have to actually wait for the 9 hours and then see how?
These are the things we want to talk on our LLM ops. Okay, the big challenge of the evaluation, right? We not done any evaluation. It's a plain vanilla fine tuning. Okay, and we did a 2 epoch, and it taken 9 hours. Okay.
Okay.
Yeah, I know these are the things we want to cover it for sure. Okay. See, the more information, right? So we want to go in a sequence. We started with the basic. If you look at our before session, right? We were going with the basics. Then we want to talk about high level of enterprise adoption. Here we discussed about the RAG and a couple of use case connect your enterprise data and connected. The next we have touched on the foundation model using API and playground. Now we are touching about the fine tune. Definitely I cannot touch upon the full pre-trained. Okay, but yeah, we can touch upon the fine tune. Next one we want to talk about the LLM ops, where we are want to cover the evaluation part also. Okay, guys.
So one question with the training data, right? So whatever data we have, right? So is it like it has to be in a specific format, or can it be like CSV, PDF, or any other format?
Any format, but your prompt template need to match that. You see that we were defining the prompt template, right? We are giving an instruction, response, answer. The prompt template we are defining, right? Based on your data sets, you can do it. See, most of the time the fine tune we will do in a structured format. Okay, we won't do like a unlabeled to trained free form. We don't do that. Okay, no, that's
No.
best of my knowledge. Okay, that if you want to do it, that you can take a base you can do the pre-training from the scratch, right? Okay, so am I answered your question, Girish?
Yes, yes, yes.
Okay,
One more thing on that, like, can you specify, like, for example, if you take any document, right? Can we specify like which fields to train on? Because a document might have a lot of columns and rows.
yeah,
And
that you can define, that you can do a prompting. That's a data processing, right? You have to do the data processing and then feed that as a, keep it as a variable and keep that information under the prompt template. Let's say if you have 10 columns, you want to interested on only 3 columns, you load the data set. Okay, but in a prompt template you only load that particular column as a variable for input. Let's say you have some traveling location, like who ordered it, when ordered it, where they ordered it. Okay, and what are their comments. Okay, what is their feedback, their traveling interest. We have 16 plus columns. Okay, you can take only 3 columns based on your requirement, and in a prompt template you can define those information and tune it.
okay. Actually, I joined little late. Like, maybe if you can quickly show me.
The lab. Okay, the lab. Okay, that's very important thing, guys. Okay, I really expect this one. I put it on the 1 minute. I'll put it on this information if on the chat. The lab which I'm doing. Okay, as I said, it's not done by me. Okay, it is done by the gentleman Phil Schmidt. Okay, so I'm sharing the information.
Thanks.
Okay. I'm here. I'm sharing here. Good, guys. Okay, you can check this one. There are one more question. How much time it took if I want to download the Llama model on one GPU machine and serve as a REST API? See, endpoint will, now we have a trained model. If you want to create an endpoint, it will take 10 minutes. Okay. See, there are multiple things when come to the operation, large language model into the production on the 3 things, right? Your latency and the amount of cost you want to pay and what is the business value. Okay. It's like a cap theorem, right? So you cannot have all at the same time. And if you want accuracy and uh, as well as the latency, you end up in paying more. Okay, if you want to download the Llama 2 model, it's a 22 GB. You can download it in your GPU machine and host it. There are only few commands, only 7 lines you can use. There are commands we can use it and host the model. We just need to load the model and deploy the model using a Sagemaker endpoint. Okay, there are multiple options which within 2 lines you can use it. You can use the This one I'm talking about the fine-tune model. If you want to deploy the base model, that is, you can directly run the jumpstart.deploy and give the model information. It quickly deploy with just a 2 line of the code. It will deploy the model. You need to just give you the information.
Hi Ajay. So can I do the same using the Terraform, like deployment, from SageMaker and all?
See, you can orchestrate. That's not a problem. You can use a Terraform to do that. That's not a problem. But I need to check whether the Terraform model is up to date. The Jumpstart is recently announced. I say within not more than 45 days back, the Jumpstart is announced. We need to see the Jumpstart module is available as the SageMaker Jumpstart module is available in Terraform or not. We need to check.
Yeah.
It's fast growing, right? So a lot of changes happening quickly.
Yeah. Ayanna, I have a question. So I'm a beginner in Gen AI. So how can I train myself and having hands-on? What do you advise?
I put the post in a LinkedIn. If you want, I can put it here again.
Yeah, please. Yeah, please. I'm a beginner.
See, unless somebody who is a researcher, okay, the day in day out they are working in a Chennai, okay, I can't call myself as an expert and all because it's changing so fast. Okay.
Okay. Thank you very much. So are you conducting any more training or?
Yeah, we have planned a few sessions. Okay, recently I gave in AWS workshop. I have given in AWS user group Bangalore for 3 hours. Okay, it was well received. And yeah, we have few more sessions lined up as part of the Cloud on Loud Tech community itself. Okay, so I'll finish off one session and then I post the next session. Okay, I can do only one in a month because I have one online and one in person per month. Okay, that's how I divided my timings. Okay, give me a minute. I'm taking that LinkedIn post I have taken.
Yeah, that's great. Thank you.
Thank you, guys. Any questions? We have another 2 minutes. I can take a question, then we can.
Yeah, there are two questions in fact. The first question is, we have multiple foundation models, right? And also we have different use cases we work every day. We know that LLM is a new journey, right? Generative AI is new thing for us. So, is there any can we map our use cases with foundation model? Which basically I'm trying to compare foundation model with the different use cases, right? Which foundation model will the best one for particular use case, something like that. Is it? Do you have any have you done anything like that in the earlier experience?
See, there is a couple of benchmark site you can check. There is something called Helm. If you heard about it, okay, there is a Helm.
Can you please
It's
put it on
holistic.
the?
Okay, here you will find your use. You can read this site. You will able to find your use case. Okay, you can find the scenario. It will tell where they do good at it. So question and answering. There is something like information retrieval. So there is a multiple model will do multiple different tasks in a better manner. I called it out, right? One size won't fit all. Okay.
Yeah, another question is you are already talked about LLM ops, right? It is in even a training that is also included. In the training, are you going to touch about how the prompt engineering is playing
I
a
covered the prompt engineering already on my previous session. If you are going to this playlist in the chat, you can check it, or if you want, you can connect me on a LinkedIn. I'll be able to give you the information. Okay.
So Ryan, actually, I'm just thinking that basically every use case, every solution depends on the end user, right? But for end user, will
Yes.
use the prompt engineer, right? If he is not using prompt engineer properly, then that has a impact on the efficiency of the solution. Obviously, right? That is the one of the most important thing that currently we're looking at. So I'm just looking at that.
That the same thing, right? It's not like people go, the chat GPT is available and how many people say I can do A to use it via chat GPT. It's all how good you are in a prompting. So like a coding, right? That's why I call it the prompting is a new way of coding. Okay. So you need to learn how to do that for your use case. At the end user, if they're not doing it, you need to give an example. If you go to the chat GPT, it'll give you an examples. You see, right? They have given you a few columns. Okay. Like that, you need to give an example. And it's a iteration. Okay.
Thank you. Thank you.
Chetan, I saw your question. I think this is the last question. Can we run Llama to quantize model on a GPU? Okay. Fortunately, that we cannot do, but I written a post. You can run a Llama to CPP on a Lambda function, which is much smaller than that. Okay. Yeah, you can
Okay,
do it.
that's great.
Okay. There are a couple of options, but there's a trade-off. Accuracy is a trade-off.
Okay.
Okay, I sent you the link where the post I have given, where the best way to start with the learning your generative AI database. Okay, thanks guys. I request everybody to give a feedback. That would be great helpful. Okay, if you have any questions, further questions, feel free to connect me on LinkedIn. I'll reply you back for sure in a convenient time.
Thank you.
Thank you. Have a great day, guys. Bye.
Thanks a lot.